Hi guys, welcome to another code film for this year. Alright guys, so already we've looked at the file extension code film, which is the film that is leading to this film that we are about to look into. And in that film, which you should see the link on your screen, we looked at we having a mail client application that is speaking to a file scanning server. And the purpose of the film was to try to demo security risks that comes along with attaching certain file types when you are sending a mail to a recipient. And we realized that due to some security risks or some business rules also, certain file types are not allowed to be sent via mail, or because they can pose a risk to the end user and also to your infrastructure. So we do not want to allow certain file types to be sent via mail. Right. So in this code film, we want to look at the mail client application bit of it. In that previous film, we realized that when we tried sending a mail, we couldn't send the mail because of an error that or an exception that was thrown. We look at the exception again, but because of that exception, we couldn't send the mail. In this code form, we want to fix that, and the way we want to fix it is to use some advanced software engineering concept or some advanced software engineering principles or practices, which will help us to solve that problem. And that's what we've titled the solid and quality attributes use case demo. So without saying much, I want us to just go into the core film so we can actually start to understand certain jargons that we've heard over time. Example is maintainable, flexible, extensible, modularity. Most of the time, if you are starting as a software engineer, you wouldn't you wouldn't appreciate it. You mostly wouldn't appreciate it, but along the line, it comes into play. So we want to look at that in this core film. All right, so we've already seen this communication that was established between the mail client app and the file scanning server, which is taking place in a certain network parameter or within a corporate space. And we made it clear that we are, as an organization, we've built a mail client app that speaks to the file scanning server. And the file scanning server is the is the is the server that is going to check whether a certain file type is allowed to be sent via the network, or we have to deny the action to send the file. So based on that, with the help of JavaScript, we tell the client what is the response or what is the expected um, action that has to take place with that file type. And when the client gets notified, if it's allowed, he can attach the file and then he can actually even go ahead and send. But if it's not allowed, he cannot even attach the file for him to even go ahead and send the file. And we did that with the help of JavaScript. Not to forget that the files that were being sent were kept in an in-memory database, just because we do not want to have a standalone production database or a standalone database which is going to store all file types that all end users will be entering into their client. We don't want that. We just kept an in-memory. It does the operation, erases it. So we do a read and write quickly, and then the memory is and the storage is gone. Later on, we'll look into some of these advanced um, architectures or system architectures with regards to persistence and data storage in another code form, which is what we're going to cover this year. All right, so with that understanding, our focus now is just on the mail client app because we can't send a file via mail assistance now, and all because we're encountering an issue. So with our use case that we are covering, the mail client app in question cannot send mail because if you do send a mail with a solution that is being implemented at the moment, the SMTP server solution is not going to work because Gmail SMTP servers are now requesting for, or Gmail account access is now requesting for some multi-factor um, attributes, or in other words, MFA. So though you have your username and password, to verify you on another level, another layer, you have to present it could be a one-time password, or it could be your phone that a code could be sent to, just to them to be sure that yes, indeed, you are the person that you are saying you are entering the mail. So we know that an end user didn't just pick your username and password and posted it into the server. No. But after that first inference, we had another way of checking because we sent it to something that belongs to you. And there's a bit of authentication, which we may look at later on in another code in regards to security or Spring security. So to be able to authenticate you, we added another layer, which is multi-factor authentication, which now Gmail has added. So without that authorization or without that verification, you can't access your mailbox to even send a mail. So using the SMTP server, we can't have that solution working because it's requesting for a one-time password uh, to 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 enter into your mailbox. So we want to find a solution to this. The application is already existing, the project is already existing, the code is already existing, and we do not want to change the behavior of the code or cause this code to become messy because of one solution we want to implement. So we are going to use solid principles and some quality attributes to actually fix it so that we can actually migrate or switch from the SMTP server solution to other solutions that are available or out there. So without talking, let's just go ahead and look at the error so we can appreciate what we really want to do. So we have our mail client app project here. This project is an application, sometimes too is regarded as a, in some contexts, the application becomes a service. But as it stands now, it's a client application. So we just say it's a client. We have a client application that we're looking at. I won't say server because this is not a server. This is an application that we're actually working with. It's a client application. But if we are looking at a case whereby we are having service, we are sending requests and getting responses, then probably we can say it's a server. But in this case, you may still want to quantify it as a server because you are sending response and receiving requests. But don't do that here because we don't want to confuse ourselves. If every implementation and its right use case or how it polymorphizes, right? It's the same as work. Every human being works, but the way a dog works is not the same way a cat works. It's not the same way a human being works. But we're all working. So they are all applications, but this time it's a client application. All right. So with this understanding, let's go ahead and just run the program and let's look at the error that we've we've been mentioning or we spoke about. Okay. So our application is on port 8088. 8088. So we'll go straight to our browser. Let's have another instance of that. Then let's go to localhost. It's already here. Then wait at the index page. So we have an application which is running on 8088. That's our mail client application which is running on 8088. So we'll go ahead and give the to address and we'll give the subject. Let me just give it some text. Hi. As it stands now, because of the solution that is working behind the scene, which has been abstracted from the end user, the from address is not being shown because we are using a Gmail SMTP server, which means that the server has a registered Gmail account, which only Gmail end users can access and send information or send mails from. The two is not an issue because that's the work of a mail server, is to distribute the mail. But the from or the end user sending the mail is the issue because it has to be an account that is registered or known by the SMTP server. So that's the first solution we are using, the SMTP server solution. This is a raw implementation which requires that there has to be an SMTP server and an account has to be registered with the SMTP server, or your account has to be known by the SMTP server. So if we go ahead and send this, we should get a response from the SMTP server. And it says mail not sent. And the reason is because of issues that we've spoken about multi-factor authentication. It says username and password not accepted. For more information, go to support and it tells you bad credentials and what have you. So from this information, we realize that the issue has to do with multi-factor authentication. Someone asks you, how do you know it's multi-factor authentication? Because if you do provide even the right password and then email, the email implementation is still not going to work. It's required. MFA is required. You can't do away with MFA. This is actually the right password for that account. And showing here by you to later, it will not be the same. So if you do actually go to this, let's go to this mail and let's enter the mail. Let's enter the you are going to enter the mailbox or that account, gmail.com. In fact, let's open with a different browser because this one it seems it has stored, it has a cookie of our activity. Let's go here where there are no storage of our objects, it's stateless. When it's ready, we'll come back and access it. So you'll go with that rather. So let's launch the Gmail. Alright, so it's private and secure mail. So let's sign in. And we sign in, we present the same username and password, and then we log into the application. So we have our username. This is our email. Is our email. Then with that ID, we also have to give our password as well. So this is even going straight to the MFA. This is actually asking for the one-time password that's been sent to your phone. Let's avoid this. Let's say try another way. Let's go with the password. So we can be sure that we are entering the right password. So we've entered the same password that we have here, which the SMTP server knows because it has the Gmail account. Good. So it says we realize that we realize that it didn't throw an error. It's actually asking us to even extend our security, and we will say not now. So good. So we actually realize that we actually access the mailbox, and these are all extra steps to take. Cancel. We don't want to look at all this, and you are signed in. That's very perfect. So you realize that we don't have an issue with this. The issue is coming from the MFA bit of it. So this you are signed in, and then not now, then it goes into the mailbox. Then we've sold through successfully. So it says mail.com, and then it actually opens your mail for you, which is perfect. So we've seen that we don't have an issue. But when we go ahead and we send with our Gmail, um, we have mail here. Yeah. So let's actually send to this, the cool films account. Let's try again. And let's see testing. We send again. It tells us mail not sent. And we've seen that it has nothing to do with the credentials as is portraying, but it has to do with MFA features that have now been tied to Gmail account. So we can't go ahead and send this. All right, so we have to fix this. So this is where we are going to use our skills or knowledge we've acquired with solid principles and quality attributes. All right, so I think it's quite clear what we want to do right now. That's what we want to do. So even before we continue, let's understand that it has to be from a Gmail account, but who you are sending to doesn't really matter. And the reason is because of we going ahead to work with an SMTP server, and the SMTP server is a Gmail SMTP server. Because of that, we cannot go ahead and send from a Yahoo Mail. It's a gmail.com registered, but it's an SMTP server it's an SMTP server application or SMTP server domain that that Gmail account exists on. So if anything that comes here is not of SMTP, is not of an SMTP implementation, the mail is not going to allow us to do it its way because it will tell you that it doesn't know that account. So it has to be something that bears or that comes or acknowledges a user name or a client at this location. Other than that, anything that is coming is not going to be accepted. All right, so without much ado, let's go ahead and now look at our solid principles that looked at. If we are now going to look at, sorry. So solid principles that are out there are 5 principles or 5 pillars that help us to write good code and also design applications that will produce some form of quality. And they are single responsibility principle, open close principle, Liskov substitution principle, interface segregation principle, dependency inversion principle. So they all have meanings and they all have their functions or their duties. The single responsibility principle governs you that just make sure that if you have a class, a module, a method, it performs only one function. It doesn't perform more than one function. The open and close principle says that you have your system, you have your entity, you have your application. Just make sure that it's possible to extend the application or extend the entity or extend whatever object you want to extend, but also make sure that it doesn't actually change the behavior. We don't actually go ahead to modify the existing solution. And then we have the Liskov substitution, which talks about the case whereby we want the same behavior irrespective of whatever subtypes that are being used. Interface segregation is also saying that don't go ahead and give me everything as a whole. If you look at your application, you realize that we have read and write operations, we have storage operations, we have data processing operations. Do not encapsulate everything into one component. It's better to have many client specific solutions than a general one. So, in other words, if you are doing something, if it's modular, read operation is one operation, it's a modular operation, it's a model. Write is also another operation. Storage is also another operation. So give me the models, give me the solution as a model, give me the read solution, give me the write solution, give me the storage solution, but don't put everything as one in a bloated form and tell me that this does everything. We don't want that. Dependency inversion principle is a very simple principle that if we have an application whereby we want to maintain the same behavior, we don't want it to behave differently when we have done certain switches or migration due to reasons known like business rules or due to reasons that favor us. It could be that we are even working with one database and we have a whole model that handles data handling with that database. It could be that now we are migrating to a different database. It should be easy for us to migrate to that new database with that implementation and its as data access object or everything in that layer without really affecting the application's behavior. It should still work as it was working. We've just made a change to the database. So that's what the dependency inversion is, the ability to have that migration done. And all that's all because of not the interface, but the Liskov substitution, which mostly boils down around interfaces. So this is just the English of it. And then we also have the quality attributes. The quality attributes being able to maintain the source code, the application. It should be flexible, it should be modular, and it should be able to extend. We are going to look at our implementation. We are going to look, and in doing that, we are going to see all this happening. You may not see this interface segregation happening, but with this understanding that we have, we are going to be able to solve our problem whereby we'll be migrating an existing solution which is heavily tied to Gmail SMTP server. We are going to make it so flexible in such a way that if I bring a new mail server, that's a new mail service to help me send a mail, it's going to be so easy to make that. It's going to be so flexible and easy to make that switch because of these principles that we've just spoken about or these attributes that we've spoken about. So we are going to just start, and so we appreciate that gradually. All right, so we have our application here. Let's start with the project structure. It's a gradual process so that we appreciate everything. Let's start with the project structure we have here. So this is our mail client app. So we built a system, and in that system we have layers. This is a, 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 a system that has been built with MVC in mind. In other words, it has an MVC pattern, or it has an architectural pattern that helps you to group your application, don't group your application, but present your objects or classes as systems or subsystems with the help of an MVC architecture. So aside it being modular or it having layers, or the right way is to say it has layers, each layer or each module solves a particular problem or handles a particular problem, or is designed for a particular um, object. We don't put all the solution in one model and say we are done. No, because when we do that, we are going to have issues. So example is what we've started here. We have pom.nothing.fox. We have the mail client controller. We have the web application. We have the mail response. Then we have the utils where we have our mail server. We're going to actually refactor this gradually so that we'll see that everything here will be presented in the right architectural pattern, and also with this right modeling that has to be done for the application. The modeling is just basically you being able to decompose the subsystems into an architectural pattern that you appreciate, and also will make everybody's life easy, able to follow, able to maintain, and also flexible for you to implement different solutions and migrations without really affecting your application behavior. So the first of all is the client controller, mail client controller. So if you go to the mail client controller, as a controller, that is where we have our logic for handling um, our expected requirements. So if the requirement is bulky and talks about so many functionalities, the client controller or the controller, as we all know, is the logic bit of it. That's what is actually going to help you to write your logics and also present your ideas to the end user. I won't go too much into controller. It's just the logic. Just put in your mind, controller is logic. That's why it's called controller. There are other layers there. So if you look at the end, if it says a 3-layer application or n-layer application, basically it has a presentation layer, which we are actually seeing. The presentation layer is what the end user is seeing. That's the template that they are seeing. We have the presentation layer. We have the business layer or the logic layer, which will be our controller. And we have the data access layer. In this case, we are not storing anything in the database. So there's no going to be any data access layer. But if we had to store something, we just have to have the data access layer. So because we are grouping them all as models, it should be easier for us to maintain the application. So if a new developer comes, he knows what he has to start searching for. So let's refactor it gradually. We can't have mail client controller and mail client web app in the same model. No. Based on single responsibility, each model has to perform only one responsibility. So if this is a model that launches the application, or this is a model that has the application start, let it be so. So we're going to save our milk client controller in a different model. And the reason is that we want it to make it easy for everybody to follow. It should be easy to maintain. And it's also with the layers that is being done, it becomes easy for your code to be more focused and well formed. So let's go ahead and create our first package. So create a new package and we'll just add controller. So let's move this one here. So we are doing the refactoring. All right, so this is perfect. So now we know that when we come to the controller layer or we come to the business layer, we will have some number of controllers over there. Right now, the only controller I have is mail client controller. So if we refresh this, F5, it becomes clearer now. Mail client, mail com dot nothing dot false dot controller. We will actually change how it's being presented so you see it better. And now we have another one for responses. We don't want to leave responses here. We want to group it into a package. So let's have a package for only responses. What's response? Let's put that also here. You can do a preview when we are not sure. Let's refactor this. Let's refresh it. Right, so it's refreshed. So this is perfect. So now we know that at the base part, we have the application that will start. So we are at the base part, which helps us to even appreciate what is happening. And we have a controller, business logic. We have where we store our responses, and we have a utils. So this is actually much more better. It's well formed, well focused, and it makes you to be able to easily maintain this. You can easily follow, and then it becomes um, very flexible to if you want to make certain switches to certain layers. If we are not happy with this controller layer, we can go ahead and build another controller layer or a business logic layer without we going ahead to destroy the whole application's organization. No, you just have to work on that layer or even let another developer give you that layer, then you go ahead and you add it to your solution. And that's possible, but we're not going to look at that. So right now, just for you to know that it makes it more well formed and it makes it more organized. It's not like before. Right. So now the next thing we want to do is that let's look at how the mail is being sent. So as it stands now, we have an email server and then we have email server. And that email server object, the instance of it is what's going to send the mail. So with that instance, we come to send mail, then we say call email server, then we do send mail. Right. So with this line of code, we go ahead and send mail. But there's an issue. The issue is that this is not working because of reasons or concerns that we've shared. So we have to actually fix this. And then it has to still be the same behavior without nothing really changing. We don't want the whole application's behavior to change just because we are sending mail. No, it's just supposed to send the mail. We are just having a problem with the mechanism we are sending a mail, which is there with the mail server. This is where we're having an issue. So we migrating to a new solution or a new way of sending a mail shouldn't affect the application's behavior, throwing new unwanted exceptions and all that you can think about. It should still work the same way as we want it to be. So how do we fix this? We realize that if you step into this mail server is a class and then the whole implementation is written over here. So in one way or another, it's not flexible because if I go back right now and I want to do another implementation, I actually have to now produce a whole new class just for this to work. So I have to actually write a whole new class and I have to actually come and change that class. If I come with a different class, this is mail server. If I come with a new, probably should have just named as the SMTP implementation. So let's refactor it. Let's rename it quickly. And then we call it SMTP, call it Gmail SMTP email server. This is much better. Gmail SMTP mail server. All right, so with this in mind, which means that we also go ahead and refactor this and just make a Gmail SMTP mail server. All right. So now you actually see that now we are having an issue because it's tightly coupled. This the mail client controller or this logic that has to send mails strongly depends on this object. So there's a dependency here. So we're actually seeing the dependency of the mail client on the SMTP server to send a mail, which is Gmail SMTP server. And unfortunately, Gmail is not helping us. We can't send a mail via Gmail because of the Gmail SMTP server, which is a vanilla implementation that we saw all because of 2FA, all because of 2FA. So this is strongly typed. We don't like this. This is not going to help us at all. So right now, if I tell you that this is just one of the solutions, one solution to send mail, which is SMTP solution or SMTP server solution. This is what's the one solution. If I tell you that there are other solutions, and the other solutions there, one could be using a public mail API. In other words, we go and speak to a mail gateway. We speak to an email gateway, and then the mail gateway will handle the sending of the mail. And then the other solution is could be that we use we use we can also use Gmail API. This one, we're just using the Gmail SMTP server, but we can actually also use the Gmail API, which is also going to speak via their original or their vanilla SMTP server, or that bare metal SMTP server. But it's going to have some functionalities which will help us to overcome the issues we are having. So if we don't want to go with the public API, whereby they've done everything for us, they've abstracted the whole flow. They've hidden everything for us. There's no way you know what's going on behind the scene. Everything is abstract. You can't see what's happening because of the encapsulation and abstraction that has taken place. You can't see how the mail is being sent. All you know is that you call a public API and it goes ahead and send the mail for you. But as to the nitty-gritty, you have no idea. That's one way. Or you could go ahead and just stick with still using Gmail API. But with Gmail API, you're actually still speaking to the Gmail SMTP server, but this time around, Gmail has built their own interface, or they've done some abstractions around certain issues that what we are encountering over here in our logs, in our console logs. So they've also found a way of building that for you. And then the other way is to also have your own mail server. That's your own mail server. Your own mail server. So if an organization with your own mail server, that's your own SMTP server installation. You go ahead and then you set up your corporate network. And in that your corporate network, on one of your virtual machines, go ahead and install your mail server. And that mail server you install is going to actually forward mails for you. But it has to come from your organization's domain. So your organization ascertain.com. Now, these are a number of solutions that we have. So just imagine that we started using Gmail SMTP server and we have the same issue. Now we have to make the changes to a new layer, a new solution. We actually now have to go into our code base and actually change this whole Gmail solution or this whole implementation. Sounds like, well, it still works, but it's not the best because it's not flexible. You're actually touching the code and it could cause a mess that you don't want to happen at all. Just imagine you have to make this change so that we can actually go to production, and then it's happened that it's not actually working with a certain principle like maybe Liskov substitution. It's working based on it being tightly coupled. The Gmail's implementation is tightly coupled to the mail client controller. So because of this tight coupling, it becomes so hard for us to implement another solution. It's extra work, which we do not want to have at all. We want to make it easy and flexible, easy to maintain, flexible to make changes, and it should also be, which also helps it being more modular. As it stands now, this is not what we want to have at all because it's tightly coupled, it's not flexible. We actually have to do another implementation altogether, and it's not good at all. It's not well formed, it's not well focused. We don't want this. We don't want this at all. So what we do is that we can say fine. Let's use the principles we know of. So one principle we know of is the Liskov substitution or the dependency inversion, which is strongly tied to interfaces. Why don't you rather build an interface? Let's have an interface here. With that interface, for any implementation that has to be used, we do not care how it will be used. All we know is that it's an interface. So whether it's Gmail, whether it is a public API, whether it's our own mail server, we don't care what's happening. All that we know is that based on our business requirement, if Gmail is not happy, is not working, we can easily make a switch to a public API without actually having this Gmail, only this Gmail instance or component tightly coupled to our mail client solution. So what we do is that, fine, we are the engineers, so let's start writing our solution. So we are going to do that with the help of interfaces. So what we do is that let's create an interface. And let's call that interface iMail service. And what that the iMail service is that it says mail server. So the email server or the email server interface is the mail service interface. We have a mail server instance, and that mail server, once we call that mail server, we can able to send the mail whether it's sending via our own mail server, Gmail server, public mail server, public email API. We do not care, or we are not really into that nitty gritties. What we know is that we call a certain mail server, we call the send action, then it sends a mail for us. So let's call this iMail server. Let's just go with that name. So we create the interface, iMail server. And where will we store this? That's also another question. Now is which package or model should we have this? So we can have a mail, we can have a mail package. So let's have a mail package. We will not keep it in the Fox. We just create a server. So you say mail, you can say mail dot, just say mail, then just say mail first. Let's just say mail, then we go ahead and click finish. All right, so we have our mail service here, and what we do is that if we'll make it auto wide. So in other words, it's just dependency injection. So mail server, and for every instance where we are calling the GTP, let's do a find and replace. So let's Control F. We replace it with mail server. So just say replace. Replace. Oh no, not that replace. Only one replace. Okay, so we do only one replace. Yeah. So now all we know is that we call mail server dot what send mail. So in our mail iMail service, we will call that method. We will call that method send mail. So we are going to define a specification. That specification is going to be called send mail. Right. You can actually go ahead and just go to the Gmail SMTP server implementation and actually copy the signature that we have over here. So we go ahead and just copy the signature over here. Then we leave that, use the signature, that same signature here. And let's make it just for don't they are all by default public. Yeah, that's an interface. Yeah, by default they are public and they are also abstract. They are public and they are also abstract. So these are signature. So this is what we have now. So if you go to our mail client controller now, you realize that we don't have an issue. It says mail server, then send mail. It doesn't even know whether it's coming from Gmail. There's Gmail SMTP server. It doesn't even know if it's coming from Gmail API. It doesn't even know if it's coming from our own mail server. So how do we confirm this? Let's do this now. So we are actually using one principle we are using here is we are depending on the Liskov Substitution principle, the LSP, and also we are doing a big advantage of relying on the extensibility attribute that you should be able to extend our application without causing much damage to it. So we are actually, well, I'll say extend, but not in the we are not actually using classes or inheritance or plugin mechanisms. No, we are just trying to extend the functionality so I can have more options to send the mail. So a little bit of extensibility, and also a little bit of looking at it. We are not making it tightly coupled, so we are making it loose coupled. So We are depending a little bit on modularity because when we make it modular, we do not have to force everything happening at once. We are creating layers for it, and each layer we create, we use the right solution or the right implementation for it. So we are gradually getting, and also with doing this, it makes it a bit, it makes it easy to maintain and also become very flexible. So all this is just happening at once. You can't say that it's all happening, and that's because of the understanding that we've gathered. This makes it very easy to maintain. It's not like previous that if we had to have a new solution, you had to actually now do an auto wired and actually call that particular instance. Let's just look at that. You have to actually call that particular instance and actually say maybe public mail server. Then you see public mail server. Then you know that you're using a public mail server. Then you have to now come search public mail server and you come and call public mail server here. Because even the public mail signature is not the same. It could be that there are differences and differences in so many other things. So we actually have to go into our code. We're actually touching our code and making all this change. And it's okay, fine. Public mail server wasn't working. Let's do another one. And we'll come at auto wired. Look at the number of times we are coming into the same code, the same class file to make all these changes. And we say, no, that one didn't work. Let's go with Gmail API service. And we say Gmail API service. Okay, this is another one. So which will come and then we come and call the send mail. So we actually realize that this is not good at all. It's going to make it our code messy. A lot of it's not going to be easy to maintain. So many issues can arise from just doing that. But with just calling an interface, whatever happens behind the background, we don't even care. We don't even bother ourselves. We just know that we call an instance of that interface or a subtype of it, then it does the work for us, then the mail is sent. How it's being sent, we do not know. All we know is that once we call an instance of it, it works. And that's with the help of the attributes that we have looked at. Alright, so now let's go ahead and let's start modeling the system to accept this interface way of going around it. And we're going to do that with the help of the the existing implementation being a subtype of the mail service. So what does that mean? So if you go to the Gmail SMTP server, as it stands now, it's a class of its own. It has no hierarchy or it belongs to no um, super type. But with the help of Liskov Substitution, all that we do is I will say implement email service. Good. So with this in mind, you can actually come and go ahead and use whatever implementation you want. So this is just one. This is using the Gmail SMTP server. Let's go ahead and let's create another instance or another solution. So this is just so we can actually go and say solution. Let's have this at top. ODS and let's just say sending mail via Gmail SMTP server. This is one of the options that we have. We don't want to, let's have other options too. So we have this in our utils package already. It's not a nice name for a mail server. We don't put in a utils package. We would probably want to have it in a different package. Try to be more well formed or well focused. So we can even say this is our mail server. Then you can have an Impl, a new package. You can have Impl. So we call this mail and we have the Impl. So at best, we could have done it mail server package, then we have the import. But because we made it a mail, we just say what are the imports for the mail server. Yep. The renaming we can look at that later, but let's look at our solution gradually. So first thing is let's move this here. Alright, so and let's delete this. We no longer need this package. So we have mail as the base package, and we have the implementations here. So this is where we have all our implementations. Going forward, if you want to even make it more specific, you could actually go ahead and say mail then gmail.impl or mail impl.gmail. That's the Gmail impl. If you also want to have the other impls, you just go ahead and name it. So let's go ahead and create another class here. Let's have the let's look at options again because we're actually fixing this. Sorry. Let's create three more impulse. Let's have the public mail API import and then the Gmail import. So we'll go ahead, new class. We'll call this the we don't even know which public mail API we'll be using. So that one could also be um another modularity and also another flexible way of making migrations because there are a number of public mail APIs there. If you go ahead and make a search for public email providers or mail APIs, public mail APIs. We have a number of them. Let's sorry, our internet is down. Right. Let's restore our search. Right, so we have a number of them, and even with the help of Google's AI assistants, we are actually seeing them list out here. So Gmail API is even listed here. So you can have a number of them, and just naming just one public mail API. Yeah, it's a generic name, but probably don't want to even expose what that's another way of doing um the solid principles, the governing with the solid principles. So you can actually have Twilio, you can have send, but the end user doesn't know where it's coming from. All we know is that based on what you switch on with the factory, we can actually just select which mail API we want to go with. So for now, we just test with the name public mail API. And to make it more focused, you could actually go ahead and break it down into the three main APIs that we want to use. As it stands now, we'll say public mail, we go the public mail server. Let's call it like that, public email server. The public email server. I don't want to say API or service, just use public mail server. Public mail, let's say API server. That one is much better. Right. So this is just one way. Then we'll still go ahead and say implement email server. Then we'll go ahead and override the methods. It's not, let's put it, control O is not working. No, shift O. Alright, so this is just one instance. We haven't even yet decided which one we'll use. Whether it is SendGrid or Twilio, we haven't, but we are actually getting there gradually. So we have the public mail API, and the last one will be with the, based on our options, the last one is, let's go with the Gmail API. Alright. And then using the Gmail API, you can actually have access to Gmail mailboxes with the authorized approach. So go ahead and add the last one class, and this is the Gmail API, and that's because as it stands now, we are actually as it stands now, we are actually using a Gmail account. So that's why we are using the Gmail API server. But if we're not using a Gmail account, um, we don't have to actually send from a Gmail API because the Gmail API is tied to a Gmail account. But because we're using a Gmail API, a Gmail account, that's why we are using the Gmail API solution around the SMTP servers issue. So we go ahead and say implement the email service. So we've seen that we've had three implementations right now. We've had the Gmail API server, Gmail SMTP server, and you also have the public email API server. So, and all this we just, or when we call it in our mail client controller, all that it has to do is it has to what? Send mail. We don't care whatever is happening behind the scene. And even the sweet case is that with the public email API, based on the provider, you can even select the provider. Based on the provider, we decide which client you actually call to send the mail. And that one too is also another step or another level. So maybe if we have the, not maybe, if we have the string, we specify the client you want to go with or the mail provider you want to go with. Once you specify it, it's this, add this in. Oh yeah, we have to give it a name. Let's say mail dot provider. So based on the provider we select, then we build the send mail around it. So we may not even want to, we are implementing from Gmail directly, but based on the implementation we want to call, we go ahead and call that particular client. So we can have a switch statement here. And then based on the mail provider that was selected at runtime, we go ahead and say we'll go with probably Twilio, because we've seen Twilio there. If you're not okay with Twilio, we'll go with SendGrid. If you're not okay with SendGrid, then we choose any other option. Right. So this is just for us to know that there are so many options over there. So that's another way. If you haven't know, okay, you can even go with Amazon implementation to us or Amazon solution. And that's all because of them building, they having their SMTP server that they've created and they built APIs around that to create more functionalities and create more experiences for sending mail. So when we are not okay with that, we can also go with Amazon SES and Rick. So based on that, we call the right client that we want to call. So you call Twilio.sendmail, and you call that of SendGrid, you call that of Amazon, you call that of uh, SendGrid, you call that of Amazon, you call that of Twilio too as well. But they will all have to bear the same. That's the interface segregation principle states that we should have many clients specific than just one bloated. So we can actually go ahead and create Twilio. We have Twilio's client, then Twilio's client will send with the same signature that SendGrid will send, same signature that Amazon will send. But we're not calling the same um, client. We are calling different client, but the implementations are the way they are sending it shouldn't change. The behavior of the application shouldn't change. We are just changing the client options, and we are using that with the principles that we know of. So this is just one way that you could go with the public API. I'll leave this here because we could actually build on this. All right. Then then maybe a default case if nothing is chosen. Okay. Okay. So if we go back now, realize that we fixed this solution with just one line of code, and we no longer have to write all those options that we were doing initially, whereby we had a number of solutions here. We no longer have to go with that. We're actually just using one line of code to handle everything. So if we go ahead and let's comment this out, we're no longer using this. We'll make this understood by Spring. So we just add the add component. Because we have so many of them, we have to specify, we have to even make it more specific. So We have to now even say this for Gmail and also how we do the injection of that too. So we have one here too. We also have the same thing to here. So we'll start with how we name this. So make this one public. Let's make it a little bit defined. Public mail API server. So that's the name of this component. Then we'll make this one to let's just go straight and type it there. So we just do Gmail API server and we'll go with the SMTP too. And the reason is that if we don't do it like this, Spring will make it known to you that it doesn't understand what you are doing. Alright, so when we come here now and we are creating our mail server based on the class we qualify, that's the class that will be injected. So if we qualify it to send, let's use a constructor injection to do that. If you qualify it to send via public API, you should send via public API. So source, create constructor using first. So you can actually go ahead and run this without doing any qualification and realize that it will throw an error. Do at auto YID, so we'll use constructor injection to do that. Alright, so we are no longer doing this. No, we've stopped doing this. Now what we are doing is we are using this approach. So let's go ahead and actually try and run this and realize that it will tell you it doesn't even know which of the implementations to use. So to make it much more appreciable, so you can actually see what's happening. You can go ahead and add some logs. So let's pick the log option from here. Sorry. Let's build it here. This is open to here. And with each of them, when it starts, you just let you know that send mail. We'll be able to find a class in the log, so we wouldn't really bother about that. But if you think you want to go ahead and also add a class, you can do that. But the class will be generated for you. So send mail. Just say inside send mail. And we'll do the same for SMTP send mail. Inside send mail. And the last option. I've looked at the Gmail. So let's look at this one too as well. Alright, so that's fantastic. So now let's go ahead and try and let's restart it all over. Let's go ahead and try and do this injection and see what will happen. So this is a dependency injection we are doing now. Realize that our mail client is not strongly tied to the Gmail instance. It's tied to any instance at all, which is making it very flexible. So it could be Gmail, it could be email, it could be Gmail, it could be public, it could be our own mail server. It's not bothered. All that it knows is that I've sent a mail and it's sent, and then the behavior didn't what change. So let's go ahead and start this. So we're using constructor injection to do this. So it will come and inject the mail server and then we'll go ahead and use it. So I don't want to clean this. I'd like to leave it here. Let's run it now. Let's clean our logs. Let's see if it even starts with so many instances. Spring is going to get confused as to which of them it has to run. So not debug, but run Java application. Good. So actually, it has actually started. It's trained those errors again. It says parameter 0 of constructor income nothing fox controller dot mail client controller. It requires a single bean, but it has found 3. So which of them is it going to use? Is it Gmail API server, Gmail SMTP server or the public email API server. It doesn't know which one to use. So it says that this may be due to missing parameter name information. Then it tells you how to actually go ahead. And you use the at qualifier approach to do that. So it says you can define a priming or you can qualify it to identify the beam that should be consumed. So there's a case whereby we come and we start work and then we realize that, all right, today we don't want to go with, today let's say we need, originally, originally we are going with Gmail. Let's actually copy that. It's good to have the names here. The names is looking out for. So originally we are going with Gmail SMTP server. So let's still go ahead and use Gmail SMTP server. So we are qualifying it now. So this is the new way that we've done this is a new migration style we are doing. We are no longer giving multiple implementation instances here. So all we do is come and qualify it, and then it will pick it up and it will send the mail. As to we coming into the code to mess it up and change everything, we stop that. This is how we are just going to do the changes. So let's go ahead and start this again and let's see what will happen. Okay, so since let's save it. All right, so everything has been cleared. Let's clear our logs, debug, sorry, runners, Java application. Okay, so this is fantastic. So it says error creating being public injection of auto dependency field. All right, so it says error creating being public API injection. All right, so let's check what this issue is because we are not supposed to have this. Let's go up and maybe there's something that we're not doing right here. Let's qualifier Gmail SMTP server. Error creating beam. Let's look at the beam. Injection of, okay, I think yeah, it's coming from here. Injection of auto dependency field. Yeah, we haven't yet created the the key for routing among the mail providers. So it's actually can't find it. So let's just put the key over there. That's what let's just put the key over there. So now we see public email provider um, key or option or channel. Yeah. So we just put it there like let's copy the right thing. Channel. And we'll see um, we want to pick the name from the public mail API, public email API. So oh, what has the name changed? So make a mail dot provider. That's the name we selected. So let's just go with it. And let's go to our properties file and let's just slam it in. And for now, it's just an empty string. We haven't yet chosen anything. Right, so this should work now. So all that we just fixed is that the public email API has a dependency on which mail provider that it should use. So it because we haven't yet set it in the properties file, it's not running or it's not working. So we have to fix that. So we'll go ahead and run this again. So it's a dependency of the public mail API server on which mail provider it should select from. So the public email API server has a number of providers. So it has a dependency on that. So you have to let it be defined in the property file so that we know which one we are going to select. So that is Twilio. You can just put Twilio for now. Let's just put Twilio. Twilio. Twilio is not there, but let's just put, you haven't yet built it around Twilio, but you've done some scaffolding around that. So just say Twilio. Let's make it Twilio. Twilio. I hope I'm spelling it right. Is it Twilio or Twilio? Just check here. Twilio. Yeah, Twilio. Twilio. Alright, so Twilio. So let's just use Twilio as it says Twilio. Alright, so we're fine. So we'll just go ahead and test this again. Alright, so right now I'm just using the Gmail SMTP. So click that, then run as Java application. Then restart it again. Voila. So you see, you see the beauty now. It's so simple, so easy. It has become very flexible too. So let's actually try and send again, and let's see if we can lock onto that. So what we'll do is that we'll no longer run it as a on the server. Let's debug it on the server, and let's create a breakpoint. So I will know that we are entering into each instances or each solution. So the first of the solution we'll create will be the let's just create the endpoint. We have one endpoint here for send mail. Let's go to the Gmail SMTP server. Let's have another endpoint here. Breakpoint, sorry, breakpoint. We are creating breakpoints. One breakpoint for send mail, one breakpoint for Gmail API. Let's create a breakpoint also for our public email API server. Alright, so we come to breakpoints. You see, we have three breakpoints. We have the Gmail, if the Gmail has more than one. You don't want more than one. You want a single breakpoint for that. So where is this happening again? Yeah, so we want it only here. So why is it? So we'll do it away with this one. So we want this one for Gmail API server, one for Gmail SMTP server, and one for the public API, public email API server. So we have three breakpoints, right? Yeah, so we have no expressions, and the outline is just the outline inside the class file. So it's our breakpoint that matters. So let's debug it on server. And our first instance we are looking at is we are looking at the we are looking at our Gmail SMTP server solution. So that's our first instance. So let's run it again. You say debug on server and Java application. So here we see the flexible switch that is happening, or the flexibility that is happening with this approach. Let's go ahead and play everything. We don't want that to stop us. Right, so now let's send a mail. Let's try and send a mail first. Then we'll see where the debug will take us to. Which of the instances or handlers to take us to, or the solutions to take us to. So let's send to a Gmail. Let's try and send to a Yahoo mail. So let's send to maybe John Doe at Yahoo. You just have let's just button. Let's say hi. Let's try and send. Good. So realize that it has landed to the Gmail SMTP server. So if you check from here, it says inside mails, send mail, then it goes ahead mail calling mail server. Then let's do a step into gradually. You want the class file. Good. Then so it says inside send mail. Right, so we've called our files. Let's go into the next line. Run this logs. I think it's also calling this um also within the that's from the mail client controller. But right now we're inside our Gmail class file, so that's what we're going to see. We have to fix this. So let's go ahead and Good. So we've seen that this is what we're looking for. So we've seen from our logs that this is send email from the Gmail SMTP mail server. That's all that we want to know, that yes, indeed, our solution is working, because we are coming out of that cumbersome solution to a single flexible solution of just using the Gmail switch with the help of the interface. So you can actually see that everything is happening. It's still working. We've been able to make our code very flexible, and then we're actually building the solution around this. And this is good news. So the other instance was being called, we have to get rid of that where it was calling a from. Can actually do this mail client controller. Mail client controller. So this is it. So is it, yes, inside send mail. Okay. So that's it's the mail client controller bit, but it's okay. Let's just leave it there. So this inside send email. Right. So we are fine. We are okay with this. What we do is that now let's switch to a different instance or solution. Let's go to the mail client. Let's switch to um let's switch to the Gmail API. So Gmail API server. Let's make sure we have the right signature for it. You can just Gmail API server. This is a quick search. So we'll pick the same attribute here and we'll paste it here. Alright, so we've changed, now we've migrated to Gmail API. Let's hit the send and see if it will launch into Gmail API too as well. Instance screen. So okay, let's launch it again. I don't know why I can't locate it. Let's go to localhost 8088. Alright, so we have this here. Now let's hit send. Let's just send to also Yahoo yahoo.com. We send hello. We send hi. So alright, so let's see where if we go to our breakpoint. So let's hit play. Let's see where it will launch to. Good. So right now I realize that it is now resolving to the Gmail API solution. So if you do another step into, we see that the logs is coming from the Gmail API server. And then the last bit of it will be with the public API solution. So let's go to the public API solution. Then let's do a quick search. Let's go with public email API server. So we'll pick the instance here. Then we'll just go back. And yeah, so now we've made another switch. So you see that we've made three switches now. We made three switches now, and then all the three switches we've made, we've been able to, let's restart this. Okay, we've been able to switch or move also smoothly among all the solutions that we have implemented. And we did this so easily with no issues at all. And we've seen it for ourselves. The last bit of the code form is actually just to send the mail. So that one will just come and we'll send the mail and then we'll be done with the code form. But the attributes we are using, or the skill or the principle we are using to do this, is what is very, very important. The mail sending, it definitely will be able to send the mail because we are developers. But as to how to make this flexible, extensible, modular, maintain, some bit of extensibility here, because it has to be able to extend it, because it has to have support for various mail options, various way of sending mails, Gmail, public email, our own email implementation, or our own email server. So it has to be there. So it's still very important. The last option is we go in the public email API server. So let's actually see if we can also make an endpoint or route to that one too as well. So let's hit at the index page. So we'll go ahead and same email address, yeah, maybe changing text. Hello, then we'll hit that. So let's see where this will launch us to. It's actually coming straight to the public email API. Right. Let's do the whole debug process because the class file is, let's start from the beginning. So we actually see the whole process. I think the other ones, it was starting from a silent execution. But if that's how the breakpoints have been set, then we have no issue. Let's start it again. And let's just hit the send button. Alright, so let's go back. And, hi. Okay, so I think that's how, yeah, it's the same. There's nothing wrong with it. So it comes straight to the public mode. So you know that we are calling from, it has done all the normal callings it has to call. It has called from the mail controller and it's calling the mail server, but it doesn't even know which mail server it's calling. When we do a step over, it tells you that it's calling from the public email API server. So by that, the mail client controller has no idea. That's a loose coupling. Has no idea, but all it knows, all we know that, or we've done the solution that is coming from the public email API server. So this is very fantastic. This is very interesting. This is so cool, so cool. So in the next one, we are going to actually test the solution that will be implemented. Then we'll be able to send the mail. So that'll be the wrap for this cool film. And I'll say that thank you so much for sticking with us to this cool film. Someone said, how do I know that it will go? Another way too of logging is actually to log all the parameters that are being sent. So that we know that it's the same parameters that are being sent to all the servers. So let's just do that. Let's just do log.info. So we'll say to email, then we'll give it a marker. Then we'll say to email, then say to email, then we'll give a comma, then we'll say subject, then we'll say body. So this is another cool way. So we just do this subject and body. So we know that we are logging the same thing to everybody. There's no difference in who we are sending it to. So the route shouldn't change the behavior. As we're stressing, the route shouldn't change the behavior. So the to mail, the subject, and then the body. So we are logging all this at once. So let's put this log in all the implementation. So we'll go to the public mail, inside send mail, then log this to as well. Then we go to the API server, then log this one as well. Yeah. So we'll do a final test. Let's bring it a little bit down. Let's make it neat. We just don't do anything. Yeah. So we'll do a final test again, and then just to be sure that we're sending the same message in mail and subject, irrespective of the channel. So I think I'm loving this. I'm really loving this. Yeah. So let's test. Let's start with the public, and we'll go to the SMTP, then the email, then we'll wrap. Right, so let's start again, debug, then we fire. Alright, so it seems our server is up and ready. Okay, so go ahead, let's go to our mail client app. Server is down, but it's up now. Let's start. So first things first, let's go to John Doe, subject, and then hello. We're not worried about the from because we've shared that the from is is known. That one is known, but the two and the from to, because it's a Gmail server, SMTP server, we have tied it to Gmail, but in other channels, we may not even have to worry about the from, but that's a very different context or different boundary conditions. So let's just put this high here. Let's see what we are looking for. So we've started the login again. So it starts with the public mail server because when we go to our mail controller, we realize that that is the dependency that has been injected into the mail client controller, which is the public email API. So if we go back here, realize that it's inside the public email API. That's where the debugger started from. Then we go ahead, look our log file. It's in the public mail API class. And even this time around, we even get to see the two, the subject and then the body. We didn't specify the form because we've explained that the form is being tied to the context or boundary conditions. But we can see that the two is John Doe, the subject is hello, and the body is hi. If you're still confused with that, we just put an equal sign here, equal sign here, then an equal sign here. And that one should even make it more clearer. So we'll do this. Yeah, when we go back, it should actually start from there. So we've done for Gmail, we've done for public API, and let's do it for the Gmail too. All right, so let's go ahead and test it again. Right, so I think this is one. This one we are using the Gmail instance. Let's stick with one. Let's use our ID. That's our Edge browser to test. So let's start again. Let's hit it. So let's even put the class file, the mail client controller. All right, and let's just test this. So let's send hi. So as usual, it has started this work again. Let's hit the next breakpoint that it goes to. So the next breakpoint is, as usual, we are inside our public mail API. So that's where we are now. So we can actually see what's happening. We send email and then, yeah. So we are inside our public email API server here, right? So that's where we're starting from. Don't worry about this. That's because we didn't restart the server. We didn't close the application to start logging. It just did this normal thing. So we are seeing this now. So this was important. We see the two, we see the subject and then the body. Um, if we type anybody at all, we didn't send anything. Yeah, there was nobody, that's why. All right, so we've seen this for the public. Now let's make the switch to another one. Let's go with what that we said we'll go with the Gmail SMTP server. So let's go with Gmail. Let's just go to that class file, Gmail SMTP server. Let's pick that object as the name. Let's go back to where we were and let's put that there. And then our restart. Let's replay. Let's restart it. It has started again. So we play. So we come back here. Then we test it again. Same signatures, nothing changes. Then hi. By this time, let's give them a body, which is here. Right. So this time you see that we're inside the Gmail SMTP server. Then we continue. Then we continue. So Gmail SMTP server, the two, the John, we are seeing everything here. And the last one, sorry, will be the Gmail API server. So let's just go to the Gmail API server. Gmail API server. And let's switch to the Gmail API server. Let's restart the server again. Let's play. So it has restarted. So we'll go and test again. So same signature and then John is here. So hit send again. And let's check our logs. So you see we're inside Gmail API, and that's what we are. The mail client controller is actually dependent on. And we're actually the debugger. And you go ahead and it has the same, it captures the same two or the recipient, the subject, and the channel same. Alright guys, so that's the demo for what we've been discussing so far. And it has been very interesting. I've also really enjoyed it. So we've actually been able to cover what we wanted to do. So we've seen it for ourselves, we've experienced it for ourselves, and we've seen that with the help of solid and some quality attributes, we've been able to we've been able to fix or solve our initial problem. The initial problem was the routing option. So we've been able to implement the fix with the help of the principles we've looked at. So our mail client has options now. All that is required now is just to integrate the options and just send them in. But as to how we got that fix or the solution to come to play is the principles that we've just looked at. With the help of the solid principles, with the help of quality attributes that we've discussed. So guys, that's it for this code film. We have actually solved our problem literally. All that we have to do now is send the mail because our mail API or our mail client app has options to select which provider it wants to go to. So we have been able to look at a use case for solid and quality attributes. All that is required right now is just making sure we can what send the mail, and that one is no longer um, a software engineering constraint. It's actually just your code implementation or your implementation with the coding that you can that has to be done. So we have actually fulfilled our agenda over here. So I want to say thank you guys for sticking with us in this code film. I've really enjoyed this code film too as well. And if you have any comments or you have anything to say about this code film, you can drop it in the description section. In the comment section, sorry. Thank you guys and see you in the last demo, which we just go ahead and send a mail with no other implementation aside what we've done, just mail sending, but no other change in behavior as we've explained, or no other unexpected exceptions that will change our logic that we already have. All right, guys, I'll see you in the last code film. Bye.